All right, this is your recording for lesson 26.2, 26.3, kind of a combination of some pieces of both of them. So in the last lesson, we looked at finding the inverses of square root functions, both from the graph and algebraically. So now we are going to take a look at the graphs and inverses of quadratics and cube root and cubic functions. So we're going to start with this graph here that you see on the side. It says use the graph of the quadratic function g of x at right to graph g inverse of x. So that shouldn't be any different than what we went over yesterday. Let me switch here to a color that you're going to be able to see, hopefully. Maybe not. Sorry. Colors. There we go. All right, so when we are given the graph and we are just graphing the inverse based on the graph, remember your best bet is to actually list points on the original and then switch the x and y's. So here in this case, for g of x, if I look at the points that I actually see there for its x and y, I see an exact point here at negative 2, 8. So right here, negative 2, 8. I see another one at negative 1, 5. Then I see 0, 4, 1, 5, and 2, 8. So all I've done is just observe the points that are already graphed in the original function g of x. To graph the inverse, remember that means we're going to switch the domain with the range. So g inverse, we just flip-flop our x and y values. So instead of negative 2, 8, it becomes 8, negative 2. Instead of negative 1, 5, it becomes 5, negative 1. Instead of 0, 4, we've got 4, 0. And then following the same pattern, we've got 5, 1, and 8, 2. So now these are our new points for our g inverse function. So I need to plot these. So 8, negative 2, right 8, down 2, and here that goes. 5, negative 1, right here. 4, 0, 5, 1, and 8, 2. So then I want to connect those points with the shape I know it's supposed to have. And there is the graph of my inverse. So that's the end of number 1 there. Remember that when you finish graphing a function with its inverse, when you look at the final product, it should be a reflection over the line y equals x. So the line that cuts diagonally through here, if you were to fold it on that green line in the middle, your blue g inverse should end up on top of g. If it doesn't, that means you didn't do the point reversal correctly. All right, so number 2 asks, is g inverse of x, so my blue, my inverse that I found, is it a function? So take a minute, really just about 30 seconds to think here. Think about what makes something a function, because we've talked about that lots and lots of times. All right, hopefully you came up with the answer no. G inverse is not a function. For your explanation, you could say one of two things. You could say there are inputs with more than one output. You can see that in the chart. Remember that if it's a function, each x has to have only one y. This x, 5, has two different y's, negative 1 and 1. So that could be an explanation. Or you could also say no, because it fails the vertical line test, or the VLT. Because if I draw a vertical line right here, for instance, it touches more than once, so it fails the vertical line test. All right, so the next thing we have to talk about is, could we come up with a test to do on the original function so that we wouldn't even have to graph the inverse to know whether the inverse would be a function or not? So we do the vertical line test to see if a graph itself is a function. What we could do to determine if the inverse is a function is what we would call the horizontal line test. So, if on the original function a horizontal line touches more than once, that means that the inverse won't be a function. Then we could also say, because this doesn't say it has to be a graphing test, so we could also say, see if each output has exactly one input. Or does each y have only one x? So these y's right here, the 8, that's repeated with different x's, so you could do it that way as well. All right, next question. What are the domain and range of G inverse? So in blue, I want you to list on your paper there the domain and the range. So I will be quiet for a few seconds here so you can think and write down your answer. All right, on the domain are my inputs, my x values. The lowest x value that I see here is 4. So it starts at 4. The highest x value, there is no limit because there's arrows going to the right. So it's 4 to infinity. The range, the y values, remember on range you look down first. When I look down, there's an arrow that would continue going down very gradually, but it would. So from negative infinity and then up to the highest y value would be at positive infinity. So there are our domain and range. Hopefully those match what you had. All right, next, it tells us that the function for g, so my original graph that I had, is g of x equals x squared plus 4. So you probably could have figured that out without them telling you based on your knowledge of the quadratic parent graph and transformations. But the next thing it wants you to do in number 5 is to find the equation for g inverse of x algebraically. So go ahead, again, take a minute or so to work through those algebraic steps of finding an inverse. Remember, first you put y in for the function notation, then you switch the x and the y, then you solve for y, and then you put your inverse notation back in. So please take the next 1 or 2 minutes to go ahead and work through those steps here. All right, if you need more time, you can pause the recording for a second to give you time to catch up. I'm going to start going through those steps. So g of x, first step is to put y in place of the function notation. So I write y equals x squared plus 4. Second step, switch x with y. So looks like that. Now I need to get y alone, so that means first I need to subtract the 4. So I've got x minus 4 equals y squared. And then y is still not alone. I need to take the square root in order to undo the squared. Now, because these are variables here, when I take the square root of both sides, I need to remember to put in a plus or a minus. So, I've got y equals plus or minus the square root of x minus 4. Last step is to replace the y again and put it back in function notation. So this time it's the inverse. So g inverse of x equals plus or minus the square root of x minus 4. Now remember, this was the equation of what I had in blue. It is not actually a function because it doesn't pass the vertical line test. So, sometimes we need the inverse of a function to be a function rather than a relation, like here, g inverse is just a relation because it doesn't pass the vertical line test. So, if I do what it says in number 6 here, if I were to take my hand and cover the right side of the graph. Now, obviously, you can't see my hand on the video, so go ahead, take your hand, cover up the right side of the original g of x function so that you're only looking at the left side. If you only had that left side of g of x, it asks, what would the inverse look like? Well, the left side here is just this part. So if I only had that part and I were looking at the reflection, that would mean that I would only end up with the bottom part of my g inverse. So that's the answer to the first part. If I only had the left side of g of x, what would the inverse look like? It would just be the bottom half of g inverse. Would it be a function? So meaning if I only had this, would it be a function? Yes, it would be a function because it would pass the vertical line test. Then it says, what would its domain and range be? Well, the domain would be the same. It still starts at 4 and goes to infinity. However, the range would definitely change. The range now, instead of having arrows on both ends, when I look down there's an arrow, so it still starts at negative infinity. But when I look up, there's an upper limit. The highest value that I see is 0. So my range would become negative infinity to 0. So what this means, because the range of the inverse, remember from yesterday's lesson, is the same as the domain of the original, that means that if we restricted the domain of the original to make x less than or equal to 0, then we would force the inverse to be a function, because if we had this domain restriction, we'd only have the 1/2 of the parabola, and the inverse would then pass the vertical line test. All right, last question on this part before we kind of start talking about cube roots and cubics for just a little bit. It says, give another possible restriction on the domain of the original, so g of x, that would ensure g inverse would be a function. So other than saying x greater than or less than or equal to 0, what would be another way we could restrict the domain that would allow it to be a function? So take about 30 seconds on this one. It's not too long of a question. Correct answer here would be x greater than or equal to 0, meaning if if instead of only having the left side of the graph, we only had the right side of the graph. That would also make the inverse a function because we'd only have the top half. So the explanation is that the inverse would only be the top half, which, just like the bottom half by itself, would pass the vertical line test. All right, so hopefully this has kind of helped to reinforce finding inverses graphically and algebraically, and also reinforced the domain restriction that we talked about in the last lesson. Next, it wants us to study these graphs here. So we've got f of x equals cube root of x with a plus 4 on the end, and then cube root of x minus 3 with a plus 5 on the end. So those are all cube roots. Then below them, we have cubic graphs. It says each cubic graph in the bottom row is the inverse of the cube root graph above it in the top row. So again, it's a reflection over that line y equals x. The graphs in the center and the right-hand column are translations of the parent functions in the left-hand column. So that's telling you that this column is for the parent graphs, cube root of x and x cubed. These ones are translations, meaning shifts. So we moved left, right, up, and or down. Number 8 says make a conjecture about the inverses of cube root and cubic functions that are translations of parents. So meaning, what do all 6, actually we should say what do all 4, because it just says the ones that are translations, so that would be these 4. So we're looking at these 4 graphs, and it says make a conjecture. So what do all 4 of those have in common? So there's more than one right answer. So take a minute, kind of discuss in your group, see if you can come up with one. All right, one that I came up with was that domain and range all go from negative infinity to infinity. So that's one conjecture you might make. Another conjecture that you might make is that they are always functions, meaning regardless of whether we're looking at the original or an inverse, all of these pass the vertical line test. So meaning if you start with this function right here in the top middle, you wouldn't have to restrict the domain in order for the inverse to be a function, because all 4 of these are already functions. So those are just 2. If you came up with something else, I'm sure you can have me check it. But those are the 2 that I thought were quick and easy to look at. So number 9 wants you to continue practicing finding the inverse of the function algebraically. So using our steps here. So on this one, because there's 2 of them, you might want to take a minute here and just pause the recording long enough to get 9A and 9B done. When you're finished with them, go ahead and unpause it so you can check your answer. So on 9A, first thing we do is take out the j of x, put y in its place. Then we switch the x and the y. And then, because we want to get y alone, in this case that would require us to cube both sides of the equation. So on the left, that gives us x cubed. On the right, the cube root and the cube disappear. So we've got y plus 3. So now to get y alone, we just have to subtract the 3 on both sides. So that gives me y equals x cubed minus 3. Final answer, because we don't leave the y equals, we have to put in inverse notation, J inverse of x equals x cubed minus 3. Sorry, my equals sign went a little crazy there. But that is our answer there. On 9b, same exact steps. First one, switch k of x out and put y in its place. Then switch the x with the y. Now I need to get y alone. Here, don't cube this yet. The radical isn't alone. So if we want to get this alone, we have to move the 5 first in this case. So you can see why we had 2 examples here instead of just 1, because your process looks a little bit different. Okay, so now the radical is alone, which means now I can get rid of it by cubing both sides. So that gives me x minus 5 cubed. You do not have to FOIL that out. We've been leaving them, in the parenthesis form. And over here we just get y. So y is now alone, which means I'm ready for my final step of putting in the inverse notation. And so k inverse of x is x minus 5 quantity to the 3rd power. All right, last thing, it wants to know what relationship we notice between the translations of the original functions and the translations of their inverses. So you can look at the equation or you can look at the actual graph. But here, my original had a vertical shift up 4. My inverse had a horizontal shift right 4. Here, horizontal right 3. Inverse had vertical up 3. Original had vertical up 5. Inverse had horizontal right 5. And you can see that in the equations here of these as well. An up 5 translated to a right 5. A left 3 translated to a down 3. So the relationship is that the vertical and horizontal changes are switched. So meaning up turns into right, left turns to down, and vice versa. So what was a vertical shift becomes a horizontal shift. What was a horizontal shift becomes a vertical shift. So that's the relationship between those translations. All right, that is all that you have for the lesson. I wrote it on the board, but I want to say it again because this is very important. The homework for tonight is going to be now on 2 different pages. So you're going to be doing page 409, number 14 through 17, and then you're going to do page 412, numbers 9 through 12. So please, please, please make sure you do the right thing. It's on the video, it's on the board. So this is your homework for tonight. See you next time.